Hi Matrix, and welcome again to another question in the past paper memo for 2019, the National Senior Certificate paper. We've gone on from algebra in the first question, and question 2 and 3 were sequence and series. Now, functions. So we are given a graph, f of x equals x squared plus bx minus 3. So that's your parabola. And gx equals a over x plus p, which is our hyperbola. We are told the parabola goes through the x-axis at 1 and 0. And we are also told that that is the asymptote of the hyperbola. So we know that the hyperbola has an asymptote of x equals 1. Okay, so the first question is write down the values of p. Okay, so the value of p in the g of x equals a over x plus p is that p is the asymptote, it's the vertical asymptote. And remember that when we're looking at the vertical asymptote, if it's on the right-hand side, then the p-value is negative. And if it's on the left-hand side, it's positive. So the graph is shifted to the right when p is negative, and it's shifted to the left when p is positive. So it's counterintuitive. If you didn't understand that, then check out my video on hyperbola graphs, which will explain that clearly. So we can see that it's on the right-hand side, which means it's negative 1. So p is equal to negative 1. Now, 4.22 says show that a is equal to 3 and b is equal to 2. So let's start with showing that a is equal to 3. So we know that g of x is equal to a over x plus p. They've told us that. And we've worked out that p is negative 1. So it's a over something minus 1. Well, let's see if we've got another point in the graph that we can work out a. D. Okay, we're not sure what x and y of our hyperbola is, so let's go to f of x. So we know that f of x is equal to didn't tell us j, did they? No. F of x is equal to x squared plus bx minus 3. Well, we know that we are given a point on the parabola 1 and 0. So we can substitute in for x and y, because remember f of x is y. So y is 0 equals 1 squared plus bx, which is what we're trying to figure out. X is 1, negative 3, and we take those to the other side, becomes 3 minus 1 equals b, and so b is equal to 2. Now, we know the equation of f of x, so we know that it intercepts the graph at minus 3, because minus 3 is the y-intercept. So we've got another point on the graph, which is 0 and minus 3, which also happens to be on the hyperbola. So we can substitute in those values in our hyperbola. We could have done that anyway, because they did tell us that it was minus 3, but I just wanted to double check. So now we've got the y value of the hyperbola we can sub in as a -3. And the x we can sub in as a 0. Okay, now to get rid of the -1, we times through by -1 on both sides. And -1 times -3 is 3. So we have a is equal to 3. Right, 4.3 says calculate the coordinates of C. Well, C is the turning point of the parabola. So all we need to do is to plug in our value for working out the turning point. We could do it by calculating the turning point formula, but a much easier way is to just put in that we know that the turning point, the x value of a turning point is equal to -b over 2a. I'm going to circle that because that is a formula that you need to remember when you are finding out the x value of a turning point. Okay? So we know that b from the first one was equal to 2. So it was -2 over 2a. Let's just write this in white. And a was 1. And so x was equal to -1, which does make sense because it's around here somewhere. And then we sub that value in to get y. So f of -1 is equal to -1 squared plus 2 times -1 minus 3. And we get 1 minus 2 minus 3, so 1 minus 5, so we get -4. So now we know that C is the coordinates are -1 and -4. So I can put that in there, -1 and -4. Okay, now they want the range of f, the possible y values of f. Okay, so I think I can actually fit that in at the bottom here, 4.4. Okay, so the range of f. Well, the range is all the possible y values, so it can be anything along here, right? But when we go below this point here, it no longer exists. So y must be the y must be greater than the minimum. And we know the minimum is from the turning point was -4. So greater than, it can also be equal to 4. So we know that the range y must be greater than or equal to -4. Okay, or if you don't have to write it like that, you could also write like this. It includes -4, and it goes all the way up to infinity. So those are two ways of writing it, and you'll get the marks for both ways of writing it. So depends on how your teacher showed you or what you feel is most comfortable. Determine the equation of the line through C that makes an angle of 45 with a positive x-axis. Okay, so the line that goes through C that makes an angle of 45 with a positive x-axis. So let's just draw that line. It goes like that. Well, if something makes a 45-degree angle with the x-axis, that means its gradient is equal to 1. But let's actually just work it out to make sure that we get the working out the method marks. Okay, so we have to know the formula. So 4.5, the formula is tan theta equals m, okay? And tan 45 equals m. And we know tan to the minus 1 of 45 is equal to 1. So we know that m is equal to 1. Okay, so we've got the gradient and we've got a point on that graph. And so we know the general formula for a graph is y equals mx plus c. We now know that m is 1. We can substitute in the point c, so which is -1 and -4. So we'll put -4. Let me do that in red so that c. So c is what we want to calculate. M we figured out is 1. So y is -4, x is -1, and m we worked out to be 1 plus c. So then that goes to the other side. -1 becomes +1 on the other side. So c equals -3. So the equation of the line is y equals x minus 3. Okay, not too difficult, and we can see that that's correct because it's going to go through this line here. So the next question is 4.6 is the straight line in question 4.5 a tangent to f? Explain your answer. Well, it's not a tangent, because if it was a tangent, the tangent, you would have to find the gradient of the graph at f of x. Because it goes through, do you see that it goes through 2 points? Because let me just expand this quickly. So I'm going to delete this so that it makes it a little bit more obvious. And I'm going to do it in pink. And let's do our line tool. So do you see D is a point on the graph? So D is a point on our line because the y-intercept of both the line that we just worked out and f of x is both 3. And it also goes through point C. So no. The line goes through C and D, which are both on F. And we know that a tangent only touches the point at only touches a graph at one point. Okay. Okay, now 4.7 says h of x is equal to f of m minus x plus q, and it has only one intercept at x equals 0. So its one intercept would be over here at x equals 0. Now, if we were to shift this, so we are looking at f of x. So this is one of those kind of more tricky questions that they're expecting only a few people to get. So this is f of x here, I've done in blue. So that is the graph of f of x, which is this parabola here. Oh, terrible. Sorry. Okay. So that's f of x, and they've said f of m minus x. So basically what they're saying is f of minus x minus x plus m. The reason I'm putting it like that is because let's look at the negative x part, f of negative x. When you, if f of x, if you make x negative x, it changes all the x values to negative. So when you change the x values to negative, you flip it about the y-axis. So the new graph suddenly is shifted about the y-axis. And so it's mirrored. So that becomes -1. Okay, so that is basically f of negative x. I'm going to mark that out, and then what I'm going to do is I'm just going to erase this. So that's the graph of f is negative x. Okay. And if I only have one x-intercept, I have to shift it up, don't I? Because at the moment it's got two x-intercepts. Over here and over here in red. So I need to shift it up. And I need to shift it up to here. Okay? In red. So, well, let me do that in green rather. So, because the shifting of the shifting up to here is the point at which there will be only one x-intercept. Above that, there will be no x-intercept. So I have to shift it up exactly by this distance here in green. Okay. So that is the Q. The Q is what shifts it up. If you're not understanding what I'm doing, just check out my functions videos where I'll explain the shifting up and down of these values. But we can see here the value of C is -4, the y value. So we've got the y value here as -4. So if I shift it up by 4, it'll hit the x-axis. So I know that Q is equal to 4. So this is equal to 4. It must be shifted up 4. Okay, the next bit is at x equals 0. So we needed to shift this green one to 0. So I'm going to do that now in a different color. It's going to look a bit of a mess, but if you're not understanding, rewind the video to the beginning of 4.7 and just watch it again. So we are shifting this point, this green, to here. So we're shifting that green point to there. Well, we know that the turning point of that C was -1, which means that because it was shifted about the y-axis, the x value of this point here is actually 1. So it's on here, it's actually on. I'm just going to erase that because it's actually on. It's actually going to be on here. Green is going to be on there. Because that is -1 and it's shifted about to +1. And so it's shifted backwards to the left by 1. so that it's hitting 0. So our M, remember a shift, we relabeled negative x plus m. So now we're looking at the M, which I'm going to just mark in burgundy because that is going to be your leftward shift, burgundy, brown, whatever you want to call it. Now, forward, if it goes forward, it's a negative. Backwards is a positive. So let's rather say to the right is forward, or to the right is negative, and backwards to the left is positive. So I'm shifting it backwards. So I'm shifting it positive 1. So M is 1 to shift it to the left. So it goes by 1. So, tricky question. I haven't done the working because I haven't got space. It's all up here. But M is equal to 1 and Q is equal to, we said 4. Okay, so tricky last question, 4.7. But yes, you can, in your final answer, what you can do is simply write to the left and to the right. So add what I've highlighted in pink into your working. Okay. Right, so that was question 4. And we will see you again soon for question 5 of the Matric Maths Past Paper 2019.